Hey guys, welcome to the first lesson in chemistry. Alright, so I will be doing some periodic lessons on chemistry, right? And today we'll be looking at the 5 main types of reactions, right? So the chemical reactions, right, are formed based on compounds being reacted together or elements being reacted together to give a new product. Right? So it's a combination of substances to give something that is new. So that's what a reaction is, right? So let's go to our first reaction, which is our simple displacement, right? Now, our simple displacement involves an element reacting with a compound, right? So if we look at this little figure here, so our box here represents an element because it is not attached to anything else, right? But this one now, this circle and this circle with here, right? This is a compound because we have a first element bonded to a second element. So this is an element and a compound, right? So what happens in a simple displacement is that the element or the atom that is not bonded to something, right? Once it is more reactive than the other metal that's bonded to something, it's going to kick it off, right? So it actually displaces it, that's why it's called a displacement, right? So this is basically better, right, than our next metal. So it kicks it off, so it now attached itself to this non-metal, and then this metal is left alone, right? So that's our single displacement, right? And in this case, let's look at an example. Calcium plus hydrochloric acid to give calcium chloride and hydrogen gas. Right? So we notice calcium is an element, right? It's not bonded to anything, so it's just Ca, right? So now it sees hydrogen being bonded to chlorine, right? So these are two elements, so we have a compound here. So because calcium is more reactive than hydrogen, it's going to take the place of hydrogen, right? Here we go. And then hydrogen now is left by itself, right? Now, please ignore these values here, the 2 here. This is just to balance the equation. The next lesson I'll do will be to help you in balancing our chemical equations, right? Our next reaction is our double displacement. So since our single displacement was an element going with a compound, our double displacement now is two compounds going at each other, right? So two elements, so now we see that this metal is bonded to a non-metal. This metal is also bonded to a non-metal, right? So what we basically do is to switch the metals, right? So this metal switches with this metal, so this takes the place of this and this takes the place of this, right? So let's look at the example, right? So we have sodium chloride plus calcium oxide. So it's sodium the metal and calcium the metal, right? So sodium takes the place of calcium, so we get sodium oxide, and calcium takes the place of sodium, we get calcium chloride, right? So this is a simpler one because we just take the metal from one, replace it with the metal from the next, that metal goes to the first one, right? And then we look at synthesis reaction. So synthesis reactions involve you using smaller substances to get a bigger one, right? So it's basically the process of creating compounds. So you have two elements being bonded together to get a compound, right? So in this case, we have nitrogen gas and hydrogen gas. When these two gases react, right? So we notice these are the small things, right? When we create it, we get a larger substance, which is a compound, we get ammonia, right? So it's two small things being bonded together to give you one larger compound. And then decomposition, right? So decomposition now is the reverse of synthesis. So we start off with a bigger compound, and it now, because of certain conditions, it will break apart to give you what actually created it in the first place, right? So with decomposition, it normally heat or electricity or a catalyst that we use to break the compound in order to get the smaller ones from it, right? So in this example, we have calcium carbonate, right? So we notice this is a big compound here, right? So when we apply heat to calcium carbonate, it breaks up to give calcium oxide and carbon dioxide, right? So we notice there is no displacement of anything because it's only the one thing that is on our reactant side, right? So it breaks up from this big molecule or compound to calcium oxide and carbon dioxide, right? And then our final reaction is combustion, or simply burning, right? So combustion is applying oxygen to an organic compound. An organic compound are compounds that has CH, right? So once a compound have C carbon and each hydrogen, whatever else is on it, right? Doesn't matter. Once it has a C and a H, right, and oxygen is applied to it, then that's a combustion reaction, right? And it always gives carbon dioxide and water, right? But not all the time it gives carbon dioxide. Sometimes it gives carbon monoxide, right? And that's something that you learn later on, right? And that's an incomplete combustion, right? So not everything in it was burnt, right? But for now, you just use carbon dioxide and water as the products for combustion, right? So this one is simpler, right? Because we always know what will be produced. So the only thing that you're looking for is if the compound has a C and a H, right? So once it has a C and a H and oxygen is being applied to it, then we get carbon dioxide always and water, right? So remember, these numbers are just there to balance up, and that's the lesson that we'll look at next time. All right, guys? So these are the 5 types of reactions that we have in chemistry, right? So there are other reactions that you learn later, like redox, right? Or acid-base reaction, which actually is based on one of these types, right? So those are the simpler types to groom in on a specific reaction, right? But these are the 5 broad areas of the types of reactions we have in chemistry, all right? So I hope you guys understand, and see you guys next time.